Hey guys, it is Mrs. Abelgarth. We are doing chapter 2, section 6, proving angles congruent. A theorem, so you guys, let's go ahead and write that down. So remember, if I highlight it, you are responsible for it. A theorem is a conjecture or the statement that you prove true. So one theorem that we're going to look at today is the vertical angle theorem. It says if two angles are vertical, then they are congruent. So that means 2 is congruent to 4 and 1 is congruent to 3. Which part of this conditional statement is the hypothesis and which part is the conclusion? So let me get my pen. So the hypothesis is if two angles are vertical, because a hypothesis always starts with the if. Angles are vertical. And I do want you guys to write this down. I'll go back and highlight it in a second. And then the conclusion is then they are congruent. And remember, congruent means that their measures, C-O-N, their measures are equal. We call the hypothesis the given part of the proof, and the conclusion is what we are trying to prove. Okay, so let me go back here. Hypothesis is if two angles are vertical. The conclusion is then they are congruent. The hypothesis is the given, and the conclusion is what you're trying to prove. So let's look at the vertical angles proof right here. This is very exciting. This is our first, like, for real, it's happening proof. So it's super excited. Okay. Given angle 1 and angle 3 are vertical angles. Angle 1 and angle 3 are vertical angles. I'm going to go ahead and snip this picture so that we can have it down below. So when we're going through this proof, we have a visualization. Because you know me, I'm a visual learner. So angle 1 and angle 3 are vertical angles. Check. We know that is given. So remember from the last section, all of the information that was first laid out for us, we called given. So we are going to take what is after given, boop, and put it as our statement. Angle 1 and angle 3 are vertical angles. True, it's given. We are going to try to prove angle 1 is congruent to angle 3. So that should be what is chilling on my very bottom line. So you put the given on the top line and what you're trying to prove on the bottom line. But please note, I will never put the word prove here. Even though I put given at the beginning for the reason, I will never use the word prove in as a reasoning in a proof. Okay, I know that sounds weird, like, that is how we are, proof, we should use this word. No, don't use this word ever within your proof. So, and my students are tempted to do it all the time because you guys are such good little detectives. I mean, good giant detectives. And you want to go, okay, here's the pattern. The pattern is given goes at the beginning, so prove has to go with it. No, that's not the pattern. So don't do that because we get it wrong. Okay, so let's look at the clue since we're giant detectives. Angles that form a linear pair are supplementary. So let's look at angles up here that form a linear pair. Well, angles 1 and 2 are a linear pair, and 2 and 3 are a linear pair. So angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. Okay, so Angles that form a linear pair are supplementary. So we're just looking at the picture, saying supplementary. Looking at the picture, saying supplementary. Now you guys are asking yourself, like, Ms. Albagarth, if I was doing this on my own, I'd have no idea. And it's okay because you've never seen the vertical angles theorem proved before. So we're going to take a journey down some proofs. We're going to observe. So this is just like say a basketball practice where coaches take walking us through the play. So he or she demonstrates the play for us, then we slowly walk through. So this is just the demonstrating our new offensive outbounding play. Okay, so our clues detective is that the sum of the measures of supplementary angles is 180. So sum means I'm going to use plus. And then is 180, anywhere we see is means an equal sign. So I'm going to say measure of angle 1 plus the measure of angle 2 equals 180. That's what this is telling me to do. Follow the clues, detectives. And I'm going to do the same thing with measure of angle 2 plus a measure of angle 3 equals 180. So even if you have no idea, like your brain is like completely blank, we are going to use these as clues. All right. So now we're going to take the 180s out of this life because we just want angle 1 and angle 3 at the end. So we got to eliminate the 180s. We also have to get rid of the 2s some way. But so if angle 1 plus angle 2 is equal to 180, and 180 is equal to the measure of angle 2 plus a measure of angle 3, well, we take that, pop that back to here, and that's a lot like this transitive property. Boom, boom, oops, boom. Sorry. So transitive property says we're going to take out the 180 and we're just going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 or 2 plus the measure of angle 3. But I would also be okay. I actually prefer substitution property for this because I can take out 180 and replace it with measure of angle 2 plus measure of everything. So either one works in this scenario. I prefer substitution, but transitive works as well. Okay, subtraction property of equality. We look at the goal. Here it is. We just want 1 and 3. Just want 1 and 3. Right now we have 1, 2, and 3. So to get rid of the 2, we're going to subtract it from both sides. And you go, oh, Miss Albagarth, please. You're saying I could subtract the measure of angle 2 from both sides? That's not good. That's not even a math thing. This is just a bunch of, it's like a chunk of letters and numbers. How dare you? And I say, it's okay. As long as it's all chunked together, you can subtract it from both sides. So then we can say, when we eliminate, so we subtract the measure of angle 2 from both sides, we have the measure of angle 1 is equal to the measure of angle 3 by the subtraction property of equality. And then we can say angle 1 is congruent to angle 3 because angles with the same measure are congruent. Another way to say, if you want to say it like this, and I'm going to throw it out there as like totally, it's completely okay to say it like this. You can say definition of congruent. And then let's be specific because we're talking angles here. Definition of congruent angles. If two angles are congruent, then they have the same measure. So we can write, so do you see this? I know guys, so subtle this difference here. But congruent angles and angles whose measure are equal, saying each one is two different things. So angle 1 is congruent to angle 3, and we made it to the end. I will be okay either with definition of congruent angles or angles with the same measure are congruent. All right, remember, if I'm going too fast, you can always pause, whatever you want to do. And in fact, this right here, angle 1 congruent to angle 3, that is our secret phrase. So if you are you missed the live session and you're making up points, please message me angle 1 congruent to angle 3. All right, so let's see it in action. This is how you guys are gonna run into it in the wild. So what is the value of x? We have these 2x plus 21 and we have 4x. They are vertical angles, so they are going to be equal. So I'm going to set it up as an equation. 2x plus 21 equals 4x. I'm going to subtract 2 x's from both sides because I want to get all my x's on one side. 2x is equal to 21. I'm then going to divide by 2. X equals half of 21. Well, half of 20 is 10, and half of 1 is 0.5. All right, I'm going to show you a paragraph proof just so that you can see it. I don't want to intimidate you with the length of it, but all I'm going to say is that we are going to take this proof here. Sorry, and yes, I want you guys to write down each one of these items. Sorry if I wasn't clear about that before. I'm going to highlight this whole box. Okay, so we're going to take 1, 2, 3, 4, 5, and 6, and we're going to make a paragraph out of it. So we're going to say, it is given that angle 1 and angle 3 are vertical angles. Angle 1 and angle 2, as well as angle 2 and angle 3, are supplementary. These angles form a linear pair, period. So we're taking each one of these items that is chilling over here, and it's reasoning, and we are writing it as a sentence. So my my English people who are like, oh, math is terrible, this is your jam. You're going to love this. So the paragraph proof says, it is given that angle 1 and angle 3 are vertical angles. Angles 1 and 2, as well as angles 2 and 3, are linear pairs and therefore are supplementary. So all it is restating. I keep toggling and it keeps resetting. Restating the things that we've done. So here. So the next thing we're going to do is say how if you're supplementary, then the sum of the measures is 180. Since they're supplementary, the sum of the measures is equal to 180. Both the sum of the measures of angles 1 and 2 and angles 2 and 3 equal 180 degrees. And therefore, the sum of the measures of angles 1 and 2 equals the sum of the measures of angles 2 and 3 due to the transitive property of equality. So all I'm doing is restating what we've already done in our column proof. By using the subtraction property of equality and subtracting the measure of angle 2 from both sides of the equation, we arrive at the measure of angle 1 equals the measure of angle 3. And since angles with the same measure are congruent, angle 1 is congruent to angle 3. Therefore, if two angles are vertical, then they are congruent. So all I did was take the 6 steps from our previous 2-column proof and make it into a paragraph. So just made it into English sentences. So it's kind of like that when you write on a check 253, it's not the number form, but the word form. All right, you guys are now headed off to the practice. Thank you, and don't forget to send me the secret phrase.